There's a method called differentiation. Differentiation comes useful when you're given an equation that shows you something, and then when you differentiate, for example, when you differentiate distance, you get speed. When you differentiate speed, you get acceleration. This also is true of population growth, rise in, let's say, like economics sometimes has differentiable formulas in it, as does engineering. Okay, so differentiation is pretty much everywhere. In order to understand the applications, we first need to be able to do our basics of it first, and then we can go to the application questions later on. You currently don't need to understand how it works. There's a full exercise based on that, and I will get to that in turn. Okay, but I just need to give you your alphabet first before you can speak, so to speak. Now, starting off, x equals x cubed. Okay, so what you can say is this. This question is y equals x cubed. Now, what the y dx means is this. The y means you're differentiating the value of y. The value of y is x cubed. So you're differentiating x cubed. You're differentiating x cubes using the letter x. That's what the bottom means, with respect to x. Differentiate y with respect to x. Y is x cubed. Now here's what you do. N is what number, guys? 3. You bring the 3 to the front. You leave the x where it is. And then you bring, it's then going to be 3 minus 1, which is 2. Long story short, bring the number to the front, take 1 away from the power. Let's try another one. Okay, I'll give you another one that's not on the list here. x7. What about x7?
7x6.
7x6. Bring the 7 to the front, take 1 away from the power. Okay, let's try another one. The next one here is going to be minus 5x squared. Now, minus 5x squared, ignore the minus 5 for a minute, just ignore it. The minus 5 is there. What happens when you differentiate x squared? What do you get? 2x to the power of 1, which is the same thing as 2x. And then minus 5 times 2x? Minus 10x, right? That's the next one. Now, let's move on to another one. When y equals 3x, now this is an interesting one, and I'll tell you why. It's equal to 3x. What happens now? The y dx equals, it's 3x to the power 1, right? So it's 3. 1 goes in front of the x, doesn't it? And then take 1 away from the power? 0. What is any number to the power of 0? 1. So it's going to be 3 times 1, which is 3. Most people don't remember that anymore. Most people just have a different way of doing it, okay? So look, I'll give you one more of these, okay? The next one is 5. 5x, okay? Now look at this. 5x. Okay. 5x. It's 5x to the power 1. You bring the 1 to the front. So it's going to be 5 times 1, which is 5. Take 1 away from the x. X to the power 0. 1. The answer is 5. Long story short, when you see 5x, you know, when you differentiate it, it's 5. When you see 10x, it's? When you see 100x? When you see kx? K. That's how you do them. Okay? Now, moving on to the next step. Okay? Next one up. We're now going to differentiate a number. If y equals minus 3. Now this one, you just got to remember it. Okay? When y is a number, any number, fraction, decimal, any number. Okay? When you differentiate it, you get 0. Always got to be 0. So if I say y equals 100, what happens when I differentiate it?
0.
Fair enough. What happens if I say y equals k? K is a constant, which means it's any number I can think of. What happens when I differentiate that?
0.
Okay, fair enough. Okay, that's your next set of rules. Now that that's done, you're now on to ones with fractions and indice powers. So example, this one here, question 9. Question 9 is y equals 2 over x3. And what you said is, well, that doesn't make sense because the x is meant to be on the top and so is the power. So what we can do here, Rory, is we can say this: x 1 over x3 equals x to the power of minus 3. You did that earlier in the year. 2x to the minus 3. Now, differentiate. And when you differentiate, the minus 3 goes to the front, multiplies by the 2. Minus 6. Take 1 away from the power. X to the minus 4. Answer in the back of the book might have changed the x to the minus 4 back into 1 over x4, which means the answer can also be written as 6 over x to the power of 4. Okay, Rory. Once again, what we're going to do next is another one. Okay. This one here. I think that's x to the power of a third, is it?
Yeah.
Okay. 6x to the power of thirds. Like last time. Bring up the third and multiply it by 6. So a third times 6, 2. Take 1 away from a third. A third minus 1. Minus 2 thirds. You can also change that into 1 over x to the power of 2 over 3. You can change x to the power minus 2 over 3 into 1 over x to the power 2 over 3 from the rules of indices. Now, what you're going to do next is, this is probably the hardest one in it, I'd say. We'll try number 14, okay? Now, number 14 looks like this. Number 14. Y equals 1 over root x. Y equals 1 over... What is root x in power mode? X to the power of? A half. Somebody was ahead of me there. I can then change this into x power minus a half. And then I can differentiate it. And what happens then? Minus a half multiplied by x. Take away minus 1. 3 over 2. I can also rewrite that as minus 1 over 2. 1 over x to the 3 over 2. Which can be written as minus 1 over 2. If you hope to get anywhere in honours maths, you need to be able to write that stuff down all its different ways. Okay?
You have to.
You should be able to.
In the test, you have to.
No, but for practice sake, do all three ways of writing, okay? Now, Fagan. Shh. Now guys, we're moving on to next. I think it's up here. Oh, here we go. Question 21 now, okay? Now, 21 looks something like this. Looks very difficult, okay? So I won't necessarily start with 21. I'll start off with a harder one like 22. Now let me show you what's happening here. Y equals 6 root x. 6 root x is the same thing as 6x to the power of? A half. Patrick. Divided by 2 to the power of? X to the power of? A half. Shh. Lads, what can I change this into?
2x minus.
Well done. Okay. Shh. Move it. Replace that. Move it in. Now, it's exactly the same as two questions put together. So what you're going to do is the first one's going to be a half multiplied by 6.
3.
Take 1 away from a half. Minus a half. Minus a half times minus 2. What is it? Plus 1, take a 1 away from the power. Now that's correct, but they also might have it expressed like this in the back of the book. 3 over x to the power of a half plus 1 to the power of x to the power of 3 over 2. Simon, just face forward with this. Okay. Now, Number 24. We gotta show you what 24 is done like, okay? 24. 2 over x minus. Now, what can I change this into? It's going to be 1 over. It's got x to the power of a half. Okay. Now, just. Sorry, guys. Just give me a second. This one here is x to the power of a third. Now, if I bring that up, that's on the bottom at the moment. I'm just going to bring it to the top. X to the power minus a third.
So why is it at x minus 2?
No. That's the middle one.
Yeah, why is that?
Oh, sorry, that's x minus a half, isn't it? Yeah. Sorry, excuse me. X minus a half. And this one here is 3x to the minus a third. Now, guys, there's one of them I haven't fixed up yet. Haven't fixed up the first one yet. 2 over x. What can I change that to? 2x minus 1. Now that you've gotten here, you're going to differentiate now. You still haven't differentiated. Okay, so what do we get when we do this, guys? We're going to get minus 1 by 2, minus 2, x to the minus 2, take away 1. Next one. Minus a half times minus 1 plus a half, take minus 3 over 2. Finally, this one here. Sorry? Plus minus 3 times minus a third. Minus 4 over 3. Okay, guys. Alright.